Good morning. We are on lesson, I will scroll up, factoring trinomials, which is lesson 8. And this is different from lesson 7. You may notice that if you look at your trinomial and look here, there is an underline A. So that A stands for the leading coefficient. So in the past we have focused on factoring trinomials when this value is just 1. So in some respects it was a little bit easier because you didn't have that leading coefficient that was over 1 that you had to deal with. Well, we're going to learn today how to tend to a trinomial if it does have that leading coefficient of that x squared that is over 1. Let's go for it. So let's do some warm-up problems first. And up here it says factor the following trinomials and check for a greatest common factor first. So what that means is if we have some kind of leading coefficient, right, that is over 1, but we can factor it out of each term, then that's a great way to factor it. But sometimes you're going to notice, and that's what the lesson is about, is that maybe this leading coefficient, maybe it doesn't go into all the other coefficients or the constant. So I have to get a little more creative. So let's go back to number 1. So I'm going to look for my 45 here. So just to review, I'm going to think of that number 45, and I'm going to list the factor pairs, right? That will give me when I add them together, will give me a 14. So I can go through my factor pair list. I know that 2 doesn't go into it. I'm going to go through all of them, and just to save time, because I think I already know what it is, I know that 5 times 9 is 45, and 5 plus 9 is also 14. So I can go ahead, and they're both positive signs, so I can basically bring down my positives, right? If you think about my template, I'm going to have x plus 5, and I'm going to have x plus 9. And again, these two add to 14, and they multiply to positive 45, and I have 2 positive signs. So I don't have to get too caught up in what signs they are, which is kind of nice. If I look at number 2, I see right off the bat that I have a negative and I have a negative sign, which means that my last 2 terms, when I find the factors of negative 28, one of them has to be a negative sign. So let's go for it. So if I have 28, I know I have 1 and 28, and again I could list all of these. I have 2 and 14, and then I have 3 doesn't go into it, but 4 and 7. Now I like the relationship between 4 and 7, and remember that I have to have a negative sign, and the negative 7 is going to win here. So now I'm just going to plot that back into my template. So I'm going to have, not x. I'm so used to saying x. I'm going to have n, rather, minus 7, and then n plus 4. And again, I'm getting these from, that's the winner right there. Okay, for number 3, let me zoom in here. So now I have a leading coefficient of 2. And I like 2 because I'm thinking that I can factor that out of everything, which is in fact true. There's not an a in each term, but I do have a 2. So I'm going to go ahead and divide it all by 2, because I'm going to get that 2 out of here. So if I take 2 out of this, I'm going to have a squared plus, well, look at that. I have 2a over 2. And then 24 minus 2 is 12, right? Okay. And now, I'm going to look here. I have 2. I'm going to hold on to. I'm going to keep outside. And now I can think about this as a trinomial that I can start factoring. So if I have 12, negative 12, I'm going to think of, well, I know that, let's see, I have 1 and 12, I have 2 and 6, that's not going to work because I need to get to 1 here. 3 and 4. Oh, 3 and 4, that's going to work. So and it's going to be a positive sign, so I think that positive 4. So this is going to be a plus 4, and then a subtract 3. That's going to work out. Okay. If I go to number 4. 4, I see, oh, well, there's a 4 that I can start factoring out of here. So I'm going to extract my 4 because that's the greatest common factor, is 4. There's no variable part, so I'm going to extract my 4. I'm going to divide everything out. So I should have p squared minus 6p plus 5. And then if I look at when it is in parentheses, I'm going to keep my 4 outside. And then I'm going to think of, well, what are my factors of 5? Well, I do know that it's prime, so it's really going to be 5 and 1, but we can go ahead and list that. So if I have 5, its factor pairs are going to be 5 and 1. And I do have a negative sign, so I think these are both going to be negative, if you think about it, because negative times negative is a positive. So I'm going to have p minus 5, p minus 1. Okay, so that's review. So now we get to this whole notion of this form. So again, when I have a leading coefficient that doesn't factor beautifully into the other terms, then there's another method that you can try. Some people call it the slip and slide, as you can see here, method. Some other people use, and when we learn how to factor by grouping, I'm going to teach you something else called the AC factor. So I want you to write this over here, AC factoring, okay? That's another method that requires grouping, but again, we will get there. But for today, we're going to learn the slip and slide. Okay, so what we're going to do is we have our A. We are going to slip A, which again, that's that leading coefficient, the leading star, right, to the end of the trinomial, and then we're going to multiply by C, which is our constant here. So that's step 1. And then we're going to factor this new trinomial out. And then we're going to divide. This is going to, it's easier if I show it to you, which I will, but divide both of your factors by what I slipped over. We're going to do some simplifying, and then we're going to put our, whatever our denominator is next to the variable. It'll make sense in just a minute. So let's go ahead and show you this in action. So in example 1, first of all, let's check our method. What is our strategy? Well, does 2, I see that has a leading coefficient, does 2 go into 5 or 3? It doesn't. X does not go into anything. So I can't really do anything with the greatest common factor. So let's go ahead and try this whole slip and slide. So what the slip and slide method is I'm going to look at my 2. I'm going to multiply it by my constant. And I'm going to rewrite that. So 2 times 3 is 6. I'm just going to write myself a note there. But I'm going to rewrite this now because I just slipped my 2 and multiplied by 3. So if I have x squared now plus 5x plus 6. Okay, and again, I got this because I multiplied 2 by 3. Now I have no coefficient here. We're going to do something with this. So our next step is that we are going to factor this out now. And how would I factor? So I need to get 2 numbers. So let's just pretend this is a regular trinomial. What 2 numbers that when I multiply them get me 6, add them, get me 5? Well, 1 and 6, that could work. 2 and 3. And I am, though, adding them together. So 6 and plus 1 would be 7. So that's not going to work. So here's my winner. So I'm now going to rewrite this into my 2 factors. If you think about my template, x plus 3, and then x plus 2. Okay. So now, so I did this. I factored this new trinomial. So check, check. I did those 2 steps. Now it says divide both your factors by what I slipped over. Well, that would just be the leading coefficient. So now it says, here are my 2 factors. I'm going to divide both of these by 2. Okay. So I did that. Now I have to reduce or simplify these fractions and slide any denominators up to the variable. Whoa, that's kind of weird. Well, first of all, can I reduce or simplify 2 over 2? Well, yeah, that just becomes 1. So here, x plus 1 goes down here. Now, on the left side, well, this is as simplified as it gets. So if it's as simplified as it gets, you can't simplify it anymore, then you multiply the 2 back over here plus 3. And that is your answer. Let's try number 2. So number 2, first of all, greatest common factor, 5 does not go into the other stuff. But let's try the slip and slide. So I'm going to rewrite this, m squared minus 17m plus 30. Now I'm going to try to factor this trinomial. So if I have 30, I'm going to try to think of some factor pairs. Let's see, 2 and 15. Ooh, that looks promising. 3 and 10. Okay, I'm going to go for 2 and 15. I think I already see it. So let's see, I'm already going to pick my template. So if I have a negative sign here and a positive, I'm going to have 2 negative signs if you think about it, right? Okay, so I'm going to have negative 15 and negative 2. When I add negative 15, negative 2, I get negative 17. When I multiply them, I get positive 30. Sweet. So our next step says to divide both your factors by this original coefficient. So what I slipped over. So here we go. I'm going to go like this. Okay. And I'm going to see if I can simplify this now. So let's see. Does 5 go into 15? It does 3 times. Oh, that's neat. So I don't have to do any sliding back over. This becomes m minus 3. Now this is simplified as it gets. So what we do here is we slide this back over and then hold on to our original constant right there. And that is the answer. Let's do one more. Okay, so let's go ahead and slip. So, and I'm going to rewrite this. So y squared minus 5y, and then 6 times 4 is 24, but negative wins. And I'm going to list my factors, 24. So I have 1 and 24, I have 2 and 12, and then I have 3 and 8. I think I got it. And they're both negative signs, so think my template. So I'm going to have to, if I move 2 negative signs, then I know that I'm going to have 2 different signs. I'm going to have y minus something and y plus something. And the negative side one over here, so the larger number in my factor pair has to be negative. Okay, next step is that, oh yeah, I should totally have boxed my answers. Over here is I'm going to divide these by 6. Because remember what I did is I multiplied this by this, so I want to undo that if you think about it here. Okay. So can I simplify this? Oh, yes, it looks like I can. So here's my template. Well, I know that 6 over 3, I can actually simplify that to 1 over 2. And now I have a half over here, and now I'm going to slide this back. So I'm going to end up with 2y plus 1. Over here, I can simplify this. I know that 2 goes into both, so 8 divided by 2 is 4. 6 divided by 2 is 3. So I end up with 4 thirds. That's as simplified as it gets. Now I'm going to slide my 3 back over. 3y minus 4. And I'm going to box my answer. To tell you the truth, I mean, there's this method, and I'm going to teach you the grouping method also. The beauty is, when you factor, there are lots of different ways you can do it. Let's just do one more. Okay. So, greatest common factor, nope. Slip c squared plus 11c. And then 12 times 5 is 60. My negative sign wins. So that's the trinomial that I'm going to factor. I've got 60. I can start listing all my factor pairs. 2 and 30, 3. Oh yeah, 3 and 20. And then 4 and 15. Oh, I already see what I like here because I'm looking for a difference of 11. So this wins. I need the negative 60. That means that these are going to be opposite signs. And I think it's going to be the 4, rather, it's going to be the 4 that's negative. Sorry, that was not that clear. Because the positive side wins, because we have a positive 11. Okay, so now let's rewrite it. So I'm going to have C plus 15, positive side 1, and then I'm going to have C minus 4. So I just took that from here. Oh man, my lights went off. Now, okay. Now I'm going to divide both of these numbers, remember, back by my original, which is 12. So I'm already seeing that 4 out of 12, there's the bell. It means you guys are coming in any minute. 4 goes into 12 3 times, so that becomes 1/3. 15 over 12. Well, I do know that both of them you can divide by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. So here are my two new fractions. And they are both in simplified form, so now I'm going to slide. And I'm going to have 4c plus 5. And I'm going to slip this over. 3c minus 1. Okay. Good luck. On the back. We could do one more, I guess, back here. This is kind of interesting. Number 7, examples of the GCF. So if you can, you may have to do all of these steps. Okay. So if I look at these numbers, I automatically think, oh, 5 goes into all of them. So can I factor these out? Oh man, this is going to be like a lot of steps. Well, yes. Let's go ahead and factor out our 5. Let's extract our 5. Well, if I divide this out, that means I have 2k squared plus 15, because 75 divided by 5 is 15. 35 divided by 5 is 7. Okay. Now, oh no. See, now I don't think 2, I can't really factor this anymore. 2 doesn't go into 15 or 7 without any remainder. So now I'm going to have to get a little creative. So I'm going to think of my factors. Let's see. I'm going to do the slip and slide. So let's rewrite this. So hopefully this makes sense. So I'm going to rewrite this. This is the slip and slide method. So up here again, I did a GCF. If I name my strategy, now I'm going to do the slip and slide. So I'm going to rewrite this. 2 times 7 is 14. Okay. Now I'm going to think of my 14 here. I'm going to think about my product sum of 14. Well, I have 1 and 14. And I have 2 and 7. Well, I already know it's going to be this one. They're both positive signs. Okay, so then I'm going to rewrite this again. Then now I have k plus 14 and k plus 1. And then, so this is all the slip and slide method. Now I have to divide by my original coefficient, which was 2. If it's in simplified form, remember, keep carrying that 2, excuse me, the 5, right? Well, 14 over 2 is actually 7. I have no remainder. So really my invisible coefficient is 1. So this becomes k plus 7. And then here, this is in simplified form, so I'm going to slide this over 2k plus 1. Okay. Good luck. This is a lot, but you can do it.